all your life and all our careers is don't let the building fall. Don't let the structure fall. And here I am taking a 7-story structure and knocking it over.
The Structural Engineering Podcast.
We've got a really cool episode this week. One that for me started with a modern steel article, but turned into much more. We're talking with Scott Collins. Scott is a structural engineer with some extremely unique work, which we'll hear about shortly. One of Scott's common clients is a YouTuber named Mr. Beast. Now, if you're younger than me, you probably know who Mr. Beast is. As if it's needed, I'll link a few videos Scott is involved with below. But because of this interaction, Scott gets to take on some of the most interesting structural puzzles. I think beyond the fun engineering story here, you can also take a bit about growing your client base and doing the type of projects that really interest you. So listen in while we learn about the big design that started this relationship, some great tips for industrial clients, and so much more. And let us know if you have any questions we can pass on to Scott. Also, pardon my edit here, but this one is starting partway through our introduction questions.
So to get you an idea, I graduated in college in 1999. Been doing this for a minute. I started the company in 2009 after the great layoff of everybody. It was like 6 months to find a job, 6 months to get paid for your first job. And I had people who wanted to work with me with my own company. So it became a no-brainer, jump off the platform and get going. The company has, ups and downs like every other company. We are currently at 6, 3 PEs, 2 EIs, and 1 director of finance.
Okay. It's a very good ratio, though. That half PE, half coming up.
We're looking probably adding a new one soon, but right now we're waiting on some bigger projects to be signed so we can get going with growing the company some more.
Yeah.
Company focuses on 3 primary areas, with obviously this side area. One is industrial. So we do a lot of pharmaceutical, crazy designs in there, clean rooms, blast valves, FRP, stainless steel, lots of different materials, lots of different purposes. Another focus we have is disaster recovery, which take a nice clean load path and go to a completely messy load path. So we have disaster world where we're dealing with going into buildings that are burnt down, crushed, blown over, run over by forklifts. We just did one that was run over by a roll-off dump truck. And then the last one is commercial. But our commercial clients tend to come to us because they have something that a lot of other engineers told them no. So they come to us because they're like, we want to do this. I'm like, okay, are you sure?
Well, that's awesome. And where are you guys based out of?
We are based out of Durham, North Carolina right now.
Okay. Well, we kind of met you, or at least I did, through your use of shirking on this project with these super trusses, which are freaking awesome. That's kind of why we wanted to sit down with you and talk about that. So could you kind of walk us through the story of the super truss? Who's the client, how that all started, and what it is in general?
Okay. But right before we get into that, you're going back in time. We met at the super trusses. Well, my introduction to you is you actually interviewed one of my earlier employees, JJ Proska. I think it was like episode 4 or 6, somewhere in the beginning. So he actually, emailed me saying, hey, you got to listen to these guys. So that was my introductions because one of my former employees was in Arizona. You guys interviewed.
Oh, that's cool. Yeah, JJ was wonderful.
So
very smart guy.
He is. He, in fact, loves to seem to digest the code books. So poor guys in Arizona have to go through his inspections department. So back in 2017, we go back to that far, we designed a cold dark shell for the purpose of being a industrial building, a pharmaceutical type structure. We had columns at 42-foot on centers. It was kind of a pentagon shaped structure, or a triangle or square with the front corner cut off of it. In 21, early or late February 21, I get a call from the architect saying, the building we designed? I'm like, yeah, it's been sitting empty. It's like, yes. Someone wants to buy it. Okay, great. They want to know if they can remove a column. Like, been there, done that one. Just, go right ahead. We can totally do that. He hangs up, goes away, comes back, called about an hour later. Like, well, actually, the new prospective owner wants to be clear about it. He wants to remove a line of columns. Well, it's like, well, that's the same detail repeated. No big deal. And he's like, okay, hangs up. A few minutes later, the architect calls and another voice is on the phone and goes, I want to be very clear. I want to remove a 4x4 grid of columns out of the building. And I have no idea who this person is. And my first statement is, sure, it's doable. Do you have stupid money? And the requirement was, what's stupid money? And I'm like, well, 5 minutes, I was like, hold on, let me get on a calculator. And I came up with a very crude number of, $1.6 million in steel. And he's like, okay, sounds good. And so after picking up my jaw off the floor, I'm like, were you seriously going to do this? He's like, yeah, give me a proposal. So I'm like, okay. So I start writing the proposal for the architect. I sent it over to him, and it was this dollar amount, 4 weeks to do it. This unknown voice calls up again, goes, can you do it in 2 weeks? It's like, yeah, let me see that proposal. Erase the dollar amount, send it back. It's like, I'm surely thinking he's not doing this.
Yeah,
this
it's not going to happen, actually. He's just teasing the number.
Yeah, he's pipe dreaming. Well, turns out it's Mr. Beast people. And after Googling who Mr. Beast was, because I'm old enough to realize I don't know who Mr. Beast is at the time, I realized, yeah, he has $1.6 million and he can spend it on a super truss and steel. Not a problem. So that is what started us off on the path of super trusses, because trying to remove 210 feet of clear span in a building of an existing building is interesting. Trying to get the proposal is written the end of February, and I get told, oh yeah, the owner wants to move in on July 1st.
I'm doing some rough math for context. 30 weeks.
So to give you some of the stats of this before we get into the details, January, February, March. Yeah, March 23rd, we had a permit meeting.
100 days to go.
So we actually had permits in hand on the 23rd. Permits in hand on the 15th. The 23rd, footings were going in. On April 1st, slab on grade was in.
91 days left.
The 9th of April, we opened up the building to make a bigger door so the steel can get in through the door with the semi-load of steel. The sound wall started going up right after the slab went up. Fire protection went in. And then we started super trusses in May 15th.
47 days, counting down.
340 tons of steel up in the air and turned over. Trusses were complete. Columns were moved by June 11th.
20 more, getting close.
And the owner had a CO on July 1st.
Wow. Oh.
So trusses up 13 weeks.
I have to assume you were really working like with the fabricator, direct contact, just to make this all happen as quick as possible.
Yeah, we actually ended up designing the trusses 3 times because in 21, steel was a very interesting commodity. Yeah. And things were going and coming quickly. So I was like, okay, what stock? We want these sizes. Well, we can't get those sizes. We can get these sizes. Design it with those sizes. Okay, I got these sizes. No, can't get that one anymore. And so we redid the trusses 3 times with steel availability issues.
What was the span of the trusses? Let's just start there with
the baby one is 168 feet. The long ones are 210.
Wow. So in each bay, you got rid of 4 columns in each.
Yep. The first bay, we got rid of 3, and then we got 4, 4, 4. So he was off by 1 column.
I especially really like this story because it just feels like it fits a typical engineering question of like, what if we did this? But then it's to the full magnitude, right? You removed, I think, almost every column but the exterior columns from this building. Is that, or is there a little bay?
So the 2 sides, it's the exterior wall. We removed the columns out all the way to the exterior walls. The other 2 bays, we did a phase 2 right after phase 1 was completed of the offices. And so we literally built a 42-foot bay perimeter on 2 sides for office spaces and stuff like that.
What was the depth of the trusses?
5.5 feet.
Really?
Yes.
210 over 5.5. That's 38 and a bit for the span to depth ratio. That's similar to a 2x6 going 17 feet or a 2x8 going about 30. Generally, we end up with the span to depth ratio in the low 20s for a steel element. So this one needed to be very stiff and a little extra wide.
That was one of the reasons why we had pairs, because we were dealing with the fact that they wanted to keep as close to 25 foot clear in the original building after all said and done.
Okay. How did you make 25 foot clear?
All except for 1 truss. The trusses that carried the 4 mechanical units deflected a little bit more. I think we're at 24 and 3 inches or something like that. So
what was the deflection of those? If you remember, just a typical live load or snow load, whatever that comment is.
Deflection allowable on the code was, after all said and done, with like 1 foot 10, something like that. So we anticipated that. We tried building camber into it, but even the self-weight, each truss was 80 kips, 88 kips or so. So just the initial deflection of the coming off it was 14 inches, just under its own weight. So it wasn't attached to the structure at that point. It was just, so the way to go back into this, how we built this, right? That's the real question. We designed the original roof. So we knew all the data on the roof. So we actually had generated a bracket that would wrap over the ends of a joist girder. So we figured out what the live load was. We said, okay, if we're doing this erection during non-snow events, non-winter events, no big hurricanes coming through, then we can use almost all that live load to hang these trusses off of. We checked the end shear of it, and we then said, okay, we can hang every 42, 48 foot section of truss off the roof. So we started on the one side and we put our columns up and we set the first 48 foot section of truss hanging off the girder. Then we put the next one in, connecting it to the girder, or the first section, and connected it to the roof of the second girder. And we built this in stages. We actually built every model in stages. So we have these staged models as well of, okay, we have one segment, two segments, three segments, four segments all together. And then the question was, how do you bring it off the roof and down? Well, this was literally a pin connection. It had one 7/8 diameter threaded rod going through two gusset plates at every truss. So we had 4 pins that had to pull out. So we got the largest forklift you could believe and pushed up on the truss, pulled out 4 pins because we had 4 lifts, and then slowly lowered it in place. So that was literally the craziest thing, because it's, you're sitting in the basket with the guys in the field because they wanted us engineers out there hand-holding. And as we're watching this lower in place and watching it mid-span going down 14 inches, and the bracket's still up there, so you can see the differences in there. It's just like, okay, that's the deflection of its self-weight.
I feel like if there is ever a project where the engineer should be on site to see how it occurs, this maybe would be the definition of it. I've had that question a couple times just to see how it's going out, but this is very fast.
Yeah, this was definitely a high speed. It also is, uniqueness because every connection was bolted. The fab shop ran it through their beamline machine, which is, if you're familiar with the beamline machine, is a machine that's able to, if the machine says load me in 1835 and make it sure it's 40 feet long, and then it will trim the first part, drill a bunch of holes, slide it, drill more holes, slide it, drill more holes, slide it, drill more holes, cuts the end, drill less holes, trim it, and slide it on out and label it, right? So they ran the beamline 24/7 for this job. And they came out with a huge erector set, all these gussets, all these plates, all these bolts. I mean, we had something like 7 pallets of bolts on the job. So it just orange boxes everywhere of bolts everywhere, 3/4 inch bolts everywhere. And so they brought all these pieces out there and they put them on sawhorses, and the guys in the field started screwing all the bolts and putting it all together and tightening it down and building it in the 48 foot sections to lift up and put in place.
In episode 77, you got to meet Connor Furster. Connor is the founder of the company Structural Python and is the creator of the live course, Python for Structural Engineers. This course focuses on teaching you how to use Python programming to make your practice more efficient, more profitable, and a lot more fun. Connor had a bunch of people ask if he could provide this course in a pre-recorded format, an asynchronous course they could fit around their work-life schedule. So, on April 25th, Connor is going to be launching just that, and it's called Python for Structural Engineers Async, but it's only for people who are currently on the mailing list.
When working on projects with strange loads, especially with oddly shaped area loads, it can be either over or under conservative to estimate them as uniform dead loads. So, using Python, Connor has put together a tool that allows engineers to determine the exact shape of a strangely shaped area load as a distributed load on a beam. And he's recorded a video demo for listeners of the podcast to check out.
Go to podcast.structuralpython.com to see this video and play around with the demonstration app. I'll put a link in the show notes. But this video is a great way to see what you could do with some Python programming knowledge. And perhaps I'll meet you in the course.
With it being such a shallow truss for its span, and you're talking, pushing these beams through, the fabrication shop. What was the biggest sizes you guys were dealing with, or and with it being, the issues with getting steel at the time, did you have to pick certain sizes just to be able to get them?
Some of them are oversized because that's the size we can get. I think one of the largest ones was a W12 by 152, and we ran them in pairs. So one of the earlier decisions because we were going so shallow, is that while you could do one truss and carry the load fairly easily, a pair of trusses took out any type of accidental torsion on the scenario. So we weren't trying to put all the load on the left side of a truss that's 4 feet deep and trying to rotate it, or 5.5 feet deep and trying to rotate it. So they're pairs, one on each side of the existing column. So as we hang these trusses up and then we lowered them in place, we then ran come-alongs to the base plates and anchored to the base plates, removed all the anchor nuts off of them, knocked all the grout out because the grout acts as a suction cup. So we knocked all the grout out. And then we literally started off, once it was on its own weight, we started at column 1, pulled it until we got base plate up, and we got it up by 1/8 of an inch. And then I said, okay, go to base column 2. And we come along that until it came up. Then we had to go back to 1 and pull it up because it was back on the ground. And then we went to 3 and pulled it up, and then back to 2 and then 4. And then so we kept going back and forth until basically all 4 columns were about 1/8 of an inch higher than they originally were.
Was that part of the design you helped out with, is like that
Yes.
staging of loading off the columns?
Yes, because we were trying to figure out, it's like you can't just transfer, a column load without preloading the truss. So we use the column's weight to preload all the dead load onto the truss.
So yeah, going back to the truss, how did you decide its geometry? I know you had some height restrictions, but so that kind of set your chords. But how did you align the webs and splice them and all of that good stuff?
So we ended up making a game out of it in the office. We do this occasionally on some of our jobs. We will have a configuration. Like we knew this truss was this long. We knew we had to meet this depth. So we said, okay, there's 3 primary truss styles, right? You got the Howe, the Pratt, and the Warren. So we said, okay, who thinks which one's going to win? So it was like, okay, if it's, so somebody picked Howe, somebody picked Pratt, somebody picked, so we picked different flavors of trusses, and the winner got to pick where we were going to take the company out for lunch. So that was what the whole bragging rights was. Okay, we're going to go to lunch anyways. It's going to be on my bill, but who's going to pick the place? What are we going to eat is kind of the question,
I really like that. That's awesome.
So
fun way to work.
So it was a little miniature competition. We had everybody make their own little Revit model. Everybody used the same live load, same dead load. We just kept it simple and said, okay, just a uniform load on a truss, do the geometry, this forward, this dip. What's your steel takeoff and what's your deflection? And Warren was the winner in this scenario. So we ended up doing Warren trusses for the configurations of them all.
The Warren truss, if you're not remembering it, is also called an equilateral truss, so there are no vertical components. James Warren patented this one in 1848, and Wikipedia would say it's ideal for use in prefabricated structures, kind of like the erection sequence we have here.
Do you remember how close the designs were from a weight perspective? Was it just massively more efficient?
It was actually probably about 10% more efficient on this configuration because we didn't have to do the verticals, and we did only verticals at key spots, so we didn't have all the verticals in the way. So when you start looking at the other twos that had so many vertical pieces, it became less efficient. Now we've done other super trusses here. We got a 261 that we just did. Our designing is the 2-story one that's on another job, and it was a different configuration that won. So again, it became a competition. Who got lunch at, picked lunch was a bet on it.
Did you run into any issues? I'm just thinking, like, anytime we put a truss in, usually there's issues with HVAC. Did you run into that? They're like, hey, we need some space to run some ductwork through, or anything specific for Mr. B's?
We actually laid this out with the mechanical guy. We had 4 lines of trusses. Each truss was different. The first one was a baby one. The second one had 4 units on it. The third one had no units on it. And the last one had 3 units on it. And then each unit was significant in weight. So we couldn't just say, well, this, that, and the other. And then the way the ducts came in is they came down and they ran parallel to the trusses, both sides. So they came below the roof framing and went, north-south, parallel to the trusses. And it's double-walled, quiet duct. I mean, you cannot hear the ducts going off of it. And you can't hear them running. You can't make any of that noise. So when they're shooting, you're not worried about, is the AC kicking on and going to wreck my shot? It's none of that going on in there.
Huh. Let's jump to foundation. That's what I'm thinking of next, is because those obviously existed. I modified a few foundations, and my thought go-to here is a helical pile, right? Because that's concealed. What did you end up using, and how big did you have to go?
We ended up it was no slab in the building. It was a cold, dark shell. It was real easy just to scrape it back, find the footing, and then add to it.
Really?
So we extended the footings from, I think there were 8s to 14s squares. So we made big rafts. They were already oversized. They were pretty well, thickness was good. So we just ended up doweling in with epoxy, a ton of rebar each direction, and then kind of connecting a big massive block underneath the slab, tying it all together.
Yeah. Was there geotech involved? Was there any settlement issues? Because now we're looking at a very big footing with pretty serious loading.
We had a geotechnical for the buildings, and they think they gave us a feedback on it. But we were already using such a low soil for its capacity, because we used what the natural soil was like 2,000, but they actually replaced 4 feet of engineering fill on the original build. So we actually had better soil than the 2,000. So we just used 2,000. So we ended up having a much better footing strength than we needed. So yes, Jimmy and them have to pay a little bit more in concrete. But I don't
if you remember this, how thick were the footings?
I have the drawings up, so I don't have to guess. They were about 18 inches thick.
Okay. I was just imagining like a 4 foot thick, like having to.
It's only a single story, which is great.
Yeah.
It's a long single story, but it's a single story. The other thing that was really nice about the way we did this is we only worried about the columns. So everything above the columns, all the joists, all the girders, weren't touched. So none of that geometry, none of the original cambers or deflections were really impacted at all. In fact, our worst displacement of the roof was like 1 inch to 1.5 inches. After connecting and walking away with all the roof, we literally had 1.5 inch movement. So, for the speed and the time that we went, it was, very nice to be able to say, look, it didn't really move the roof.
Yeah, that's some impressive engineering and construction. I mean, I would have thought things would be wobbly and moved all over the place. Did you find that kind of, the roofing stayed the same? You guys didn't touch anything above, other than maybe cut some holes for some rooftop units, or did they have to re-slope?
Nope. Everything the slopes stayed the same. The drainage was still running. They did rerun the internal drains, because the drains were going down by the columns that we removed. So they had to run them out. And if you look at, some of Mr. Beast's videos, if you look carefully, you'll see some of the white, roof drain leaders running below the ceiling grid just a bit, because it was running deeper than where they wanted the ceiling grid. But you'd have to be very tentative to watch that, because they go quickly.
Was there any ponding? And this is something I really don't know anything about, but I know that it exists. Ponding concerns with the deflection there?
We checked that. It was not a big concern, because we had good slope drainage with secondary drains on it. And we had and we didn't deal with like tiny little 4-inch drains. We had like 8 16-inch drain leaders going down through the building. So it could remove a whole lot of water. And, and where this building's located, they do get a lot of rain. Not a lot of snow, but do get a lot of rain.
So from building up from the foundation, what were the columns like? What were the connections? How did that all work?
So we did a pin base. So we had an 18-inch column, 18 by something. Hold on. It was something large. 18 by 175s for the columns. They were at the top. We did a roller pin on one side and a slider on the other side.
Okay.
So when you look at bridges, they do it all the time. When we do our buildings, we tend not to actually, quote, make our structure rotate on purpose.
Right. Yeah.
So we actually had a top chord and a bottom chord sliding capabilities on one side and a rotation capability on the other side.
Gosh, I like that. I like, your connection there with bridges. I love it going out and seeing a bridge with just a huge pin, and they're so literal how their connections work, it seems like, on most bridges.
Yeah. This one had like conslide bearing pads on it, which allowed for the rotation and the sliding. The way that it was configured, you couldn't, this is where the shurikens came in. We're next to the brand new wall or to the exterior wall. You couldn't get your hand up and around and in some of these locations. So we ended up designing with shurikens in key spots because you couldn't, once we started setting up truss members, you couldn't get back there to put the bolt in and hold the nut. So we kind of, I joked with Ted, who made the shurikens, that my first 4 projects using shurikens, none of them involved an HSS. So it's like your whole purpose of this was an HSS, and I didn't use it a single time. It took like my 5th job before I used an HSS splice connection.
Gosh.
So,
With the beam deflecting, I don't know how to actually phrase this very well, but how much did it move to influence the column that was supporting it? Like you were saying, kind of a bearing-ish condition. How much was that kicking out?
the rotation?
Well, yes.
The rotation was, I kept the drawings up. I kept it up just for that question. See, we wanted a 1.2 degree rotation.
Okay.
And a 96 kip bearing capacity.
So what is, kind of even stepping back further just to the building itself, what is the lateral system of the building? And I'm guessing you didn't have to change that with taking out interior columns.
No, we didn't. Well, actually, we did add 340 tons of steel, which is no small dead load increase, but we had the capacity in it. The lateral system was a combination of steel brace frames and precast shear walls. Okay. So we had North Carolina's an interesting state. You can literally have seismic control one direction and wind control the other direction based on your aspect ratios of the building. So you could literally, it's kind of joke because it's the only state that you really have to think both directions and, different seismic directions as well.
Where are you at in the seismic design category and then like a wind speed?
So we're usually in about a C typically. Sometimes you get to B, sometimes you get into D, depending on where you're at in the state. And then wind speeds, we go from the coast of 150 to the mountains at like 90 to upper elevations to 110. So we have a wide variety of wind speeds and seismic speed events. So
was there any special loading considerations with this? I mean, are you randomly a category 4 for some crazy reason, or a 3? Like, did you increase risk?
We did not increase the risk, but we did take the time, because you think about it, and a lot of, I'm going to say I do it too. Economically, engineering is you're going to take the uplift pressure at the corner zone and apply it to the whole roof, because that's just the easiest to do. Or you're taking zone 2 and applying it to the whole roof and just check the corners. Well, this we did bands. And we actually had, H distance from this is this, and H or half H is this, 2H is this. And so we actually had all these bands of wind loads going both directions, or all 4 directions on the trusses, trying to figure out, this truss is 42 feet from the edge, so it's going to get all of first zone and a little bit of the second zone, causing uplift on it. And we did all that detail analysis and realized that these things were weighing so much that it kind of just laughed at the wind uplift. There was no uplift load on it ever.
Wow. Dang. Was there any, like, while you only had a few weeks to design this, was there any big changes that Mr. Beast's team made to you, or requests that made it even, more challenging of a design?
No, once we got they're pretty good at, once they actually commit to what they're doing, they turn us loose on the engineering to make sure it works. On all the projects we've got done, is we were able to get going. Now, their second, the first video, we left the hooks, the pad eyes that we used to bring it down with the loading, we left them in place. First video that was filmed in it was, 100 people in a circle. And what did they do is they took that nice pad eye and they hung a tire swing from it. So you're like, well, it's a tire swing. It's a 200-pound, 300-pound person at most. No real big deal. The next video, I get a call saying, can we hang a 4,000-pound piggy bank from the truss? and you're kind of like scratching your head. It's like, you want a what? So, and that was used for Squid Games. And if you look really careful, you can find the 1 second flash of the piggy bank hanging from the trusses. But you got to know where to look and when to look.
I feel like, hindsight's always 2020, but knowing the questions they've asked, which we're going to get into here in a little bit, but would you have added in some extra point load capacity in that truss?
Probably. We actually did a concept for phase 3 of this building, which was mimicking the 210-foot spans with a request for additional robustness in the roof. And that was the way they put it, like additional robustness. And I'm like, what is additional robustness? I mean,
undefined robustness.
Yeah, undefined. Well, we ended up starting using Teslas as a measurement for them. It's like, well, they can hold 1 Tesla in mid span. Is that good? It's like, no, we want more. It's like, can we do, so can we do in zone? So we went through a big giant concept of what if, and we ended up scrapping that concept. But that particular one had a 36-foot clear and 210-foot spans, but they were 14-foot deep trusses, and they could literally carry a huge truss on that.
I think Structure Magazine needs to have a section just for you on a monthly basis of what did Mr. Beast ask Scott this month.
Yeah,
loading on the roof.
Yeah, it's not like can I put an RT unit up the roof? That's like, that's don't worry about that.
Oh man. Okay, so yeah, going back to the construction side, was like, you designed the building, you saw it get built originally. Now you're coming back, taking out 15 columns or so. While you're going through that whole process, was there any variation from settlement of the foundations to construction tolerances from the original design or construction, I guess, that created any challenges?
So that we ended up solving that in our bracket. So our bracket hanging from the roof is a 2 pieces of 6x8 angle, this long leg vertical pointing down. We had a little bar going across that had a 1/4-inch threaded rod that connected the 2 angles, so it would not separate across our seats. Then we had plates come down. On our 8-inch leg, we had, like, the first hole was 1.5 inches up. The second hole was like 1 inch up, and the next hole was like 2 inches up. And then we had similar hole punches of different configurations on the plate that went down. So if they needed to adjust up a 1/2 inch, they just kind of shifted which holes they lined it up and then put the bolts that connected the plates in a different set of holes. So they had 6 different holes to play with at slightly different spacings, like a 1/2 inch off spacings. So they had, several inches, of adjustment capability in the connection plate to these angles that were wrapped over the bar joist seats that came down to a gusset plates of the threaded rod through pin. So if any type of differential settlements or aging settlements type stuff was accounted for by basically having the connection bracket adjustable in the field, so the guys took it out as they went.
Gosh. Okay, so since you're messing with a bar joist system, those traditionally just are built with camber to them. You mentioned camber to your truss. Did you have to do any field modifications since every column you removed held an element that had camber, so there's almost a sine wave to the roof, basically?
So again, with the fact that we took out just the columns, all that camber and all the bar joists stayed as they were. We didn't have to touch them at all. So all that system stayed exactly what it was. We just basically replaced the column going to the ground to the column going to the truss. And it became a vertical member every 42 feet in the truss system.
And so the trusses, the open web trusses that were there, are in between basically 2 truss elements that you created?
Yep. Yeah, we have so the girders are going perpendicular to the trusses, and the bar joists are going parallel. And there is a single what was the column line truss is going between the 2 trusses, because there is an 8-inch or 16-inch gap, 14-inch center line to center line of truss. So there was a gap for that truss to sit there.
And then the loading's purely just occurring where the existing truss or the existing columns were. So
correct.
4-point loads on this truss. That's genius.
So that entire roof stayed where it was. I I was since told by the CEO that he saved $7 million doing our super trusses versus buying a property and building a new building on. And I was like, man, I really underestimated my fee.
It is a good pat on the back, I suppose, that it's very functional, but
Yeah.
that's a double the fee sort of comment also.
Yeah. It's like, I could, but yeah, in the long sense, it's made a good relationship. What we've been able to deal with and do with Mr. Beast, as they would be our fun client. I think everybody should have at least one fun client. And, Mr. Beast has definitely been one of our quote fun clients to deal with.
So you mentioned you've done some more super trusses. Where else are you seeing that this is occurring? Did your article on the super truss come out and all of a sudden everyone's calling you on doing them, or what are you seeing there?
A lot, one of our primary sectors is the industrial, and so these industrial clients are like, I need to put this paint system in, or I need to put in this packaging line, and they're like, well, my packaging line is costing me $10 million or $50 million, and your building cost is like $2 million, $3 million, and so they're like, I don't care where your columns are, they're not here, so they are very clear that they don't want columns in their packaging line. So all of a sudden you got this, I can't put a column in a 40-foot span in this direction and longer in that direction. So you usually try to take your span the short direction you can. The problem is that sometimes that short direction span is 147 feet. So you get a 147-foot span because their line takes that much room, and they don't want to deal with your building columns in a way with their line, because their line isn't quote set until probably after the equipment is placed and showing up. And even then they still want to have some wiggle room, like, oh, that conveyor would be a little bit better if I scooted this over 3 feet and make it cleaner. So the column being in the way is a big deal for some of these pharmaceutical and industrial manufacturers. One of our jobs, we literally have them, we designed trusses and they came back and said, hey, we want to put a conveyor system off your trusses. It's only 1.2 million pounds of conveyor system hanging off your 146-foot spans with 16 cycles per hour, which comes out to, go look in the back of the steel manual for fatigue cycles and fatigue failures. So we tend to get clients just because we're not afraid to say, okay, it's just a little bit more math. Let's just go on, see what you got, and let's go on and solve the problem.
And you asked probably the same question you asked at the beginning of this is, well, do you have stupid money? We can do
sometimes sometimes it is that way. Sometimes you're dealing with pharmaceutical companies, and you're like, yeah, you already got stupid money. That's already been established. So we're just going to keep going. Like you're telling me that the equipment you're putting in is, $80 million. So my $10 million building doesn't matter. I'm just an umbrella for your building. So whatever I want to do is just reasonable at this point.
So what other cool things, were part of the design or construction of this truss that we haven't asked yet or we haven't gone into that you think would be interesting?
I think one of the interesting things is the fact that, all this was field bolted, including splices. So our splice plates were 1.5 inches thick and 42 inches long with bolts at 3 inches on center. So we literally had guys out there putting in bolts forever, it seemed like.
How big were the HSS again? I think you said, but I can't picture this.
The original HSSs?
Yes.
Were 8-inch columns, 8x8s. So with everything in there and sandwiched together, we had, a very rapid speed put together truss. It definitely took the team to do it. I would definitely say that the fabricator being able to run a beamline machine and tell us what parts to get or what steel pieces they can get, and the back and forth interaction with the fabricator that we had, and the contractor on site being willing to listen to us and having that, conversation with the old iron worker who's sitting there having fun with us on site by, scooting the basket of the cherry picker underneath the trusses as it's starting to be pulled down in place, just to, hear the beams and stuff settle in place and pick on you about it, which is, it's fun. It's unique. Not every engineer gets to be out in the field and figure out how these bolts are going in place and hear the beams talk as they lower in place.
Yeah, usually we're out there because it's not going together and they're upset, not because they want us to be there.
Yeah, there's been several projects that I've worked on throughout the years that the contractor's like, yeah, okay, this is crazy. I want the engineer out here. And, one time I asked the guy, do you want me to stand on it or below it? And he just kind of like laughed at me. He's like, okay, there's an engineer that's confident about his design.
So before we move away from the Super Trust, tell us about the Shuriken. I think probably a lot of people listening aren't fully sure about it. If you're not, you should listen to the episode we did with Ted. But how did you use it? Why were you comfortable with it? Give us those backgrounds.
Well, I mean, looking at after the episode, listened to it, I was like, oh, that's great. And literally, I think it aired, and about a month later, we start getting calls from Mr. Beast. So it's like I already had that fresh in my mind. It's like, oh, this is great because I can already see spots that you're not going to be able to reach to it and get to it. So I think we were one of the first projects to start using shurikens. And this had a small amount of shurikens. But then phase 2 was we finished the studios portion of it and we went right into the office portion. Well, we just built all that sound wall. So they couldn't put the new columns or tie to the old columns because they had a wall. So we ended up putting shurikens in all the shear tabs so they could just put the beam right up against the shear tab and then run all the bolts in. So that was the second use of it. It's like, okay, we had opportunities to put all these shear tabs on with shurikens and just stand up the columns right next to the wall and then put it together and not have to deal with damaging that sound rated wall, which is literally, they were filming Squid Games as we were building phase 2. So
wow. What was your fabricator's comfortability with it?
At first, JD was a little bit more like, you want him to do what? But now he actually, I think he does keep some of them in stock. Partly because I use them a lot now, but also because he's seen the value of them themselves. They thought at first it was a little bit of a pain, but now that they've used it, they're like, oh, this works a lot. The funny thing is that when it was first priced for this job, he's like, it's like $80 for a piece. And I'm like, what? So I look back on the line. It's like, no, it's $80 for 16. And he's like, oh, that's much cheaper. So it was definitely more of a, oh, this isn't as expensive as I thought it was going to be.
That's really good to hear. Yeah. Yeah. We really enjoy talking with Ted, and he's such a great guy. So
yeah, I keep sending Ted the details I generate of projects that are using his shurikens off brand. And he has made animations from some of them. And so it's kind of a give and take relationship there because I think this product's great. But I've like, well, I just used your product for yet a different approach. So here you go. And so he's getting more and more examples of how to use it off brand, not through HSS centers. So.
Well, cool. Well, I think that's, kind of wrapping up there, the Super Trust. We want to move into how you became, and I think we probably have an idea now, but became pretty much Mr. Beast's whole team's structural engineer. You're the guy they go to. Give us that intro, and then let's move into some of the projects you've gotten to work on.
So, yeah. So, hanging out with the CEO and the other people out there, Mr. Beast, it's become, with the first job and the second job, it's become like, okay, you got a crazy problem, send it us way. We'll see if we can't help you out with it. There's got to be a way to try to do what you want to do reasonably safe. It has gone into a wide variety of videos. Some of them we quote get paid for. Some of them is just 20 questions on, can we do XYZ? By far, one of my favorite videos so far that we've been involved in has lasted a whole whopping 40 seconds of airtime. And it was the Dominos. We got a call from one of the producers that we want to do the world's tallest dominoes. And I was trying to figure out, what do you mean? It's like, well, you've seen the videos where the kids have the dominoes all stacked up and you click and it goes up, 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 all the way down. It's like, yeah. And you've seen them get bigger. I'm like, well, yeah. It's like, well, we want to beat the world record. I'm like, well, what is the current world's record? So we're on the phone. I'm Googling it. Current world record's 23 feet. It's like, okay, that's not hard to beat. 23 feet, 24, 25, 26. He's like, no, we want to like shatter it. It's like, so I was like, what are we talking about? 80 feet.
Oh my gosh.
And I was like, 80 feet. He's like, okay. So we're like, how do we build an 80-foot domino economically? And so we came up with shipping containers. And so we stacked the 16th domino and we said, okay, a shipping container is 8.5 feet tall, 4, 8 feet wide and 40 feet long. Well, what's the aspect ratio of a standard domino? Scale it up. Where does that get us in dominoes? And so it's 76.5 feet tall, 40 feet wide, and 8 feet deep would be the scaled version of a domino. So that was number 16. Coming backwards, we found an MIT paper on progressive domino collapse with the theoretical mathematics behind creating a cascade that would continue going. Well, like all good academic papers, they either assumed hollow or they assumed solid. And we had the first 10. No, the first 10 were solid. And then the next 6 were not solid. So we're like, okay, that confuses things. And then it's also, based on having a relative scaled mass capability. And then also the paper didn't take in the real fact of that this energy, as it keeps building, can seriously lose energy by denting and oil canning your structure.
Yeah.
So we had to then figure out what the falling impact was of a domino and its preceding weights pushing on to your next domino at a key spot. So the first 10 were all solid wood. That was easy, right? Just 2x4 stacked together until you get the right geometry, cut them to the shape, and there you go. Paint them in their dominoes. 11 through 15 were cold form metal framed with plywood. So the last cold form frame one was 53 feet tall, because this is scalable, right? So you're getting to the 76 foot tall one, but the one below it has to be big enough to knock that one over. So you get these different weights because you're going with cold form framing, and I had to reinforce where the impact zones were on the first impact and then its impact on the next guy. So we had to deal with impact zones going up this chain to the shipping container. And then they later told us, oh yeah, we're going to put a 7-Eleven on the backside of the 76-foot domino. And it's like, do you think it's going to crush it? And I was like, yeah, it weighs 86,000 pounds. It's going to make that into a flat pancake, and without a problem. And so they built a 7-Eleven, and they put the ice machine and water bottles and all that, making it look like a real store. And when it fell, it's like half-inch thick is what the store is, because it literally just blew it away and crushed it.
And I'm guessing you had one chance. Like, your math had to be good. They weren't going to take it twice.
Right. It was not something easy to reset. That was for sure. So yeah, we ended up doing that. And literally it was like, okay, I'm taking a complete theoretical math and seeing if I can make it into reality.
Knowing that we have sort of safety factors in many instances, did you have a built-in, like, this is a little more than the math would say we need?
We had some of that, but we also had the opposite intuitive, right? We had to make sure it did fall. So the other fun thing about this event is we did tie the dominoes down because we knew we had to stack them, and it wasn't going to be like, I'm going to stack them in 5 minutes. So we ended up stacking them, and we had to check the load case of what if a storm comes through. Okay, I don't want it to fall when wind blowing. I want it to fall when I start the 1.5-inch tall domino, but I don't want it. And so during setup, we had the 76-foot tall one up. We had the 53-foot tall one up, and we were setting up some of the lower ones. But as we set one, we'd tether it down to the ground. We actually, as I was driving out to that set that day, I went through a big giant storm. I got there, and the big giant storm caught up to me. Less than 25 miles from the crow flies, Pfizer gets hit by a tornado, like an EF2 tornado, 25 miles away. So we're like, okay, I guess what's good we did to check to make sure the wind didn't blow it over, because we got a solid load test of probably 30 plus miles an hour wind on these dominoes that had no base, just sitting there with tethers at the top.
Wow. Were you there on site when they pushed them all over?
I was indeed there when they knocked them over there. Me and the erector were behind the scenes, and we're like, yeah.
I bet it's just a really unique feeling for you, because I'm sure Mr. B's was like, wow, it worked. That's wonderful. But for you, it's like you really did the math there, and you get to see, like, you made this.
Like, it's like, yes, it did work. But it was a little more, interesting because on that one, just because it was all your life and all our careers is don't let the building fall. Don't let the structure fall. And here I am taking a 7-story structure and knocking it over. So it was, it's very anti-structural engineering almost. It's like I had to make sure the structure could take all these hits and impacts and crushes a building, but I couldn't make it so it wouldn't fall over.
When I'm putting like a list together in my mind of like the coolest structural things you could do in your career, I think everything about this, like all the things you've done with Mr. Beast, is like on the top of everything. The one other thing I want to know, like he has a lot of videos where he blows things up. Are you involved with the explosive stuff?
I am not involved in explosives. I kind of draw that line. It's like guys, I can do lots of things. There are certain things I don't do. Explosives is one of those. Not that I wouldn't love to do it. That was one of my earlier thoughts of being in a career path, doing implosions for buildings. But I was like, no, that blowing something up while it'd be cool and fun is not my strong suit.
Well, I'm just thinking with all the stuff you do with disaster relief, you've got a very interesting plethora of information and knowledge. Where does blowing things up fit in there? But
yeah, it is interesting because when you go into, I was called down to the Charlotte 5-alarm fire in Charlotte, North Carolina, and the firefighters needed to get on top of the podium deck, but they heard what they said sounded like shotguns going off. And of the 15 engineers in North Carolina that are on the first responders, I was the one who's done PT slab podiums before. So they asked me to come down there because some were like, I don't know what's going on. And, can you get on a slab that if the PTs are gone? So when I get to site, I start walking around the building because that's the first thing you do is walk around the perimeter. I have found plugs about 50 feet away from all the PT tenons blowing out. These blocks all across the street. So I found, dozens of these plugs going around there. And then when we finally got enough information from the engineer record on what the design entailed, I could do back of the napkin stuff saying, look, we could probably get access to it, but we need to verify what it looks like below and how much spalling and stuff is in there. So when we started wading through the ankle deep water, because they were still putting water on the deck, putting the fire out, as we're walking in the building, looking at the slab damage below. And there was PT tendons draping like spaghetti in the slab.
Oh, gosh. Okay. I have a sort of a silly question. Well, it's not sort of, it's entirely. Do cities ever ask for sort of your engineering permit to approve any of these designs? Like, I know no one's living in it, so it's not really a safety thing, but there is something weird happening, and they probably want to know that someone looked at it.
So there's a couple different things going on. Several set designs studios or filming studios have gotten, I'm going to call it like a standing permit. They have ability to build a temporary structure as they want, and the building inspector has to be notified of what they're building and what the purpose is. Now, that being said, something like Dominos or some of the other crazy things, Mr. Beast people are like, yeah, we want someone to kind of check this. North Carolina is going through a permit change and updating its building code. So we're going to be probably looking at temporary structures a little bit more in depth, like the IBC building code is on the 24. And so we'll probably have, requirements that if it's occupied spaces, it's got to be designed for, a reduced wind speed, a reduced live loads, exiting requirements need to be met. So there are some things that will affect some of their shoots going forward, like, exiting on when you put 100 people in a circle. Do they have enough exiting for it? Do they have enough structure for it? Is it a safe structure to be in for sleeping in for the next 10 days, type structure. So there will be some requirements coming up, but certain, pockets or zones have created a studio TV video friendly set design so that they can have a little bit more. I'm just building a set wall here for a video shoot, So it's not like it's going to be occupied. The only person's going to be there are the people building it, and then the, actors and actresses or, talent.
So are they bringing in other consultants as well, or mostly just a structural engineer?
They have a pretty good construction crew that knows their limits. So they'll have augmenting construction people coming in. They also have electrical engineer and architect that they bring in too as well. So we just had a request for a shoot concept and they want to light it up with enough lights to power a small city, we kind of joke about. And they want to know, what size generator do we need? And I'm like, I don't do generators. It's like, but I know a guy. It's like, your electrical guy who's doing the other 3 buildings will gladly size a generator for you to make sure you get the right size generator.
So with that, you're getting, just out of curiosity, contracted directly through Mr. Beast. You're not working through an architect or a third party.
We do both. We have the buildings are usually through the architect. We have 3 buildings currently under design with them, and we have 2 sets that are directly through them currently.
So you told us also before, and I'd love for you to tell the story again if you can, about the Mr. Beast burger and the questions that came up with that.
So the CEO knows me, knows us, and we done some projects together. And so I get a call from him and one of his producers, and he says, "Hey, the New Jersey engineer of record for the mall won't let us put a 2,000-pound burger on the second floor." And I'm like, okay, first license statement is, I am not licensed in New Jersey, so I can talk questions through you, but I can't help you out with any engineering. He's like, that's fine. We just want to try to figure this out. I said, well, you need to take the 2,000-pound burger and spread it out to 100 pounds a square foot. You need to spread it out and make a skid on it. How big is a 2,000-pound burger? Because I have no idea. He goes, it's about a 7-foot diameter burger. It's like, okay, well, can it fit through a double door somewhere? It's like, yes, there's 2 double doors that are like 4 feet wide. We can roll it in. It's like, okay, so we're now taking a skid that's holding this burger that makes about a 20 square foot area that we're going to roll in. Coming in from where? He goes, the second level or the third level of a parking garage. And I'm like, and this is a precast parking garage. He's like, well, yes. How'd you know? I said, well, it's a mall. That's what they tend to go with. So why are we doing the burger on the thing? So, well, we want to put the meat, the oven, and the trailer on the 3rd story of this parking garage. I'm like, well, how are you going to get a semi through a parking garage? Because they're normally about 7 foot clear, and a semi's closer to 12 foot. Oh, we'll have to take a crane and pick up the semi ice, refrigerator trailer, set it up on there, along with the 2,000 pounds of meat, along with the oven to cook it all, and the skid to put it in and roll it in there. I said, so now we need a crane reinforcing the parking garage, a skid, the oven, all that up there, to roll it through the garage to put it on the 2nd floor. Is this the only place you can do it? And the producer's like, no, it's just the best. So it's like, well, where else can you stick it? Ground floor over here. And I'm like, that would probably make things a lot easier. And so all of a sudden the CEO's, well, put it on the ground floor over there. You just saved me $300,000 or more. Thanks, Scott. Bill me. I'm like, I'm not billing you for 20 questions. It's like, it's just, I was making sure this is what we really wanted to do before we started putting in $300,000 into cranes and reinforcement and skids and everything else to get this thing in there.
Yeah, you really did your job as a consultant, right? It's not always to be there to solve the problem they want to be solved. It's to consult them to get to where they maybe should be sometimes.
Right. There's been other questions like, hey, we're running a train through a brick wall. Is this a concern for derailing the train? I'm like, probably not. But, because the train weighs a lot and the bricks will kind of move out of the way. And so it shouldn't be a problem. But if you're worried about it, put some black corrugated pipe over the tracks and it will bounce the bricks out of the way and the black corrugated pipe will go away because it's not going to withstand any strength.
How many projects have you done for Mr. Beast?
I was adding it up. I think paid videos, we are 1, 2, 3, 4, I think. And unpaid, we've helped out with another 3 or 4.
Gosh. I think this is just what you would dream about in college of like the coolest thing an engineer could do. It's the make-believe version.
So me and the CEO were joking about it, and he started adding them up. He's like, well, you worked on your first building, did 100 people in a circle. And that's like 400, 500 million views. And then you helped a little bit on Squid Game. So that's another 400, 500 million views. And then you helped on 1 to 100. Well, that's another 4 or 5 people views. And then is like, and you did every country for $250,000. Well, that's another, so we started adding up and we're getting close to like 1.2 billion views when we were doing it. And it's like, I may be the most viewed unknown engineer in the world at this point, but you know what? Who cares? It's just kind of funny. It's like, it's not like any engineer is known really. I mean, Mark Robert's probably the famous engineer that there is in YouTube right now. And, James keeps telling me, or the CEO keeps telling me, like, hey, we need to get you and Mark to meet, because when Mark went into the studio and saw those trusses, he went, holy cow, was his reaction. It's like, well, that's cool. I'd love to meet him, but, I haven't got that opportunity yet.
That's so cool. I know watching some of his videos, they go internationally and do some stuff. Have you done anything outside the country from a consulting standpoint?
No, we keep it to states I'm licensed in for the most part, Texas and North Carolina here, because those are his two filming bases. And those tend to be the ones that he's building stuff on. The international, like the philanthropy channel, is usually done through organizations or tag teaming with organizations. So he does a lot of good work that way. The shoots that require engineering are usually the ones that they want to keep close to home so they can have control over building it and not have to worry about fighting a bunch of city halls or permitting offices on trying to do something crazy. That's why they have a couple ranches out in Texas that allow them to shoot cannons and tanks and stuff like that. And they have their own property over here in North Carolina, allows them to do stuff like build structures and take them back down. Like the escape room challenge. That was another fun one where they wanted we called it the Borg ship in-house, but it was a 30-foot tall, 30-foot wide, 30-foot deep wood frame structure with no floors. So we had to do 30-foot tall walls of wood with no structures. And they painted it gray, so it was like literally like a Star Wars Borg ship out there in the field for 3 weeks.
Dang, that's awesome. I saw one the other day, and I was thinking about you. $1 million, and then you gotta cover it up so a tank won't blow it up or catch it on fire or whatever. And I was like, man, Scott would be the guy. Like, they should do the episode with a structural engineer to see how good could an engineer that problem, but make it really tough. Maybe drop a cruise ship on it. I don't know. Why are you so willing to take on projects and designs that other engineers aren't? What makes you want to take on what others would see as more risk?
So I was fortunate or unfortunate, depending on the way you want to look at it, is I worked at a large firm when I first graduated college. So I started out in school. I was drafting. I had my first 2 buildings designed and signed and sealed and built prior to graduating college even. So I was way ahead of the power curve. So when I went to a firm in Texas, which was one of the largest structural engineering firms, it was just a pure structural engineering firm at the time. And I was doing tilt wall warehouses for a while, and then I got dragged into another group that was doing odd projects. And for whatever reason, I was deemed the guy that this client wants a building made of non-magnetic metal. Build us a building of non-magnetic metal. That's a lot harder than you think to put a non-ferrous building together. And then it was, okay, you did that one. Okay, we're redoing a dome on a school, on a university, but we got to reframe it, and we got to design the scaffolding system to cantilever over this dome structure on the existing roof. So go figure out how to build the dome and how to support the scaffolding on this existing roof that was not designed to carry all that counterweighting. And so it just progressed that way. And I kind of joked with them that every time a new magazine came out, structures, whatever the cover project was, as I got to do the next one just like it. FRP. Okay, here's FRP project. Here's a now FRP rebar. No one in the company has done FRP rebar. You're doing it. So I became the guy who got to read the code books and figure out all the implications of whatever that new material or new idea is, So it became kind of a theme. And so when I moved back to the Carolinas, I started in the pharmaceutical world. Well, we're dealing with pharmaceutical equipment. Well, this thing can blow up, or as the British calls it, this one burps. And it's like, what's a burp? Well, it blows up and it breaks about 80,000 pounds of force vertically. Keep it in place, please. Don't let it leave the building. So you have this random stuff. And, I got a blender. It's the size of a Volkswagen, and it's starting with concrete. So when it cranks up, it puts a torsion on the structure of some ridiculous amount of, newtons coming around in circles on this torque. So you have this huge shear force on your structure base plates. So I just started collecting weird jobs, and I just started enjoying them and just kept progressing. So when I get calls for weird jobs, I'm just like, okay, let's see what you got and see if you got the budget for it and see if we can do it. Because I don't really, one of my mentors said, hey, look, if you can prove mathematically works, he'll sign it. So there has been many discussions where it was, hey, this is what we're dealing with, and here's what I did to do it. And he's like, great, looks good. Here's the seal. Go forth and have it built.
I like that. I like that way of thought too. If we can prove it by math, let's go ahead and do it.
And a lot of even like our Mr. B stuff, we literally just started off with, what's the uniform load on a beam? Okay, it's this much moment. Well, I have 6.5 feet to deal with. What's my deflection limits of that beam? Okay, my I needs to be this. Okay, A over D squared. Figure out what my area of steel needs to be on the two ends. That's how I came up with the tonnage. It was not complex math. It was back to basics of what was my deflection limit on the beam.
I think that back to basics is like often lost. To be able to quickly run those numbers is a skill.
I'm now, like I said, 25 years into this. So nowadays I'm the old guy saying, yeah, you need 1835s there. And they're looking, my young engineers looking at me like, you didn't even break out a steel book. It's like, no, it's because I did that 40-foot span so many times now. That's an 1835. That's all you got to know. You can go check it now.
Well, Scott, thank you for joining us on the podcast. We really enjoyed hearing about this and excited about maybe some future episodes together with you and talking about more about the work you do with Mr. Beast and upcoming projects. So thank you.
Yep. Thank you.